Our first example in lesson B is about finding the perimeter of a figure. To start with, you would want to separate this figure out, because here on the end we have a semicircle, then there's a rectangle, and then we have a triangle. First, I'll start by finding this semicircle length, or circumference. The circumference of a circle is 2 pi r. And since this is only a semicircle, we're going to be dividing that amount by 2. So we'll have 2 times pi, and the radius is also 2, and that'll be divided by 2. So here we could simplify this by 2 and go ahead and divide these 2. So we would have 2 pi, which if we put in 3.14 for our pi value, we would have 6.28. So that's our end length that we're looking for. Then we'll just add the other lengths to this amount. So we'll add 4, and we'll add a 7, and we'll add a 5. Okay, so when we add the 6.28 plus 4, we'll have 10.28 plus 7 plus 5. Those will stay the same at this point because again we're working left to right. Then we'll add 10.28 plus 7, so that'll be 17.28 plus 5, and then we'll just have to add 17.28 plus 5, which is 22.28. And in our instructions it says that the dimensions are in meters, and this is just perimeter, so we just have to label that in meters, and that is our answer. In our second example in lesson B, we're finding the area of the shaded portion of a figure, and the dimensions again are in meters. Now I've shaded the area that we're actually looking for in green, and we're going to start by finding the area of the largest rectangle, and then we'll separately find the area of that circle and triangle, and then we'll just have to subtract the areas of the circle and triangle from the area of the rectangle. So let's start out with that area of the rectangle. And that is 10 times 15, which is 150 meters squared. And then we'll find the area of the circle, which is pi r squared, so we're going to have pi times 4 squared. So we have 3.14, I said the one, didn't write it, times 16. Which is 50.24. And then we'll find the area of the triangle, which is 1/2 times 6 times 5. We'll have 3 times 5 is 15, and again these are in meters squared. So then we'll take the 150 from the area of our rectangle, write that down, and we're going to subtract 50.24, and that was the area of a circle, and we'll subtract 15 because that was the area of our triangle. This is 114.76 meters squared. Our third example in lesson B is to find the volume of the cylinder. The area of the base is 242 meters squared, and then it gives us the height in the picture. So since we already have the area of the base, we just need to multiply that times the height. So 242 times 10 is 2,420, and that's going to be meters cubed. Volume is cubed. The fourth example in lesson B is to find the volume of the cone, and it's kind of an odd base-shaped cone, but they give us the area of the base as being 242 meters squared. So again, we're going to multiply the base times the height, but this time we also have to multiply that by 1/3 to find out what the volume of the cone is. So earlier in example 3, we had already multiplied that together. I'll go ahead and write that out again. 242 times 10 equals 2,420 meters cubed. And then we're multiplying this 2,420 times 1/3. So when we multiply that together, we're going to get 806.67 approximately meters cubed. And then that's our answer for the volume of this cone. The fifth example in lesson B is to find the volume of a sphere whose radius is 3 centimeters. The volume of a sphere is 4/3 pi r cubed. So we're just going to fill in our radius and multiply this together. Okay, so 3 cubed is 27. And then we multiply 27 times 4, we get 108. And then when we divide 108 by 3, we get 36. Now, you can leave the pi in, and that is a correct answer. And don't forget to label that centimeters cubed. But there are certain times when you might want to multiply that out and fill in 3.14 for the pi. 36 times 3.14 would give us 113.04 centimeters cubed. So both of these answers are correct for the volume of the sphere. For our sixth example in lesson B, we're going to find the surface area of the right prism. all dimensions are in centimeters. And again, I am not the best drawer here, so you can look in your book for a better picture of that right prism. What we're going to do first, now that we've found the area of the two triangles, we're going to find the perimeter of the triangle. So we're going to add 4 plus 3 plus 5. And this is 12, and then what we're going to do is multiply 12 times 6, which is our height. And that's going to be in centimeters squared, and the 12 is also in centimeters squared, so we're going to add those two together. So we'll have 84 centimeters squared, since it's area, as the surface area of our right prism. The 7th example in lesson B is to find the surface area of the right circular cylinder that's shown, and dimensions are in meters. So first, we'll want to find the area of the top and bottom bases, and they're circles, so we have pi r squared, and since there's 2, we'll be multiplying our answer by 2. So we'll have 3.14 times 4 squared. So we'll have 16 times 3.14, which is 50.24. And again, since there are 2, we're going to be multiplying that answer by 2. Which equals 148. And it's in meters, so meters squared. Okay, then we need to find our lateral area. Now, if we were to open this up, we would have a rectangle, and 10 meters would stay the same as our height, but this length here is the circumference of the circle, so that's 2 pi r. So our circumference is going to be 2 times 3.14 times 4. So we'll have 6.28 times 4, which is 25.12, and we're going to then multiply that times 10. So it'll be 251.2 meters squared. Now we're not done yet. We have to add this area here, that was the top and the bottom, and this area here, which is the area of the side. So we're going to have 251.2 plus 100.48. 351